All right, we're going to take a quick look at degrees versus radians. Both of these are ways to measure an angle. Degrees typically talks about the measure of the angle. The radians is referring to the distance the angle has to open. So really, it's referring to the same thing, the overall size of an angle. So if I had an angle something like this, and we said it was 30 degrees. That would be the size of that angle. If I were to grab a protractor and measure it, I would measure it at 30 degrees. In radians, we would say that this is a pi 6 radians. Pi over 6 would be that distance. So we're saying it's a pi 6 units from start to finish measuring that angle. So again, two different ways of measuring the angles. We're going to look at working back and forth between degrees and radians. Most of what we would see in higher mathematics and sciences will typically be radians. It is used a little bit more universally. So we want to be able to make the adjustment back and forth to that. So first off, to convert to radians. If I want to get a radian measure from a degree, we're going to multiply by pi over 180 degrees. Okay. So if I wanted to take, I'll start with that 30-degree angle that I had. If I want to take 30 degrees and convert this over, I'm going to take that 30 degrees, multiply it by pi over 180. And this is where we can reduce the fractions. So 30 will go into 186 times. And there's where I got that pi over 6. If I want 100 degrees, I'm going to convert that to radians. I'm going to multiply it by pi over 180. So let's see, we can reduce this. I can make that 10 pi over 18, which reduces further to 5 pi over 9 radians. Okay? So I can convert any degree measure to radians by multiplying by pi over 180. Sometimes we're going to end up with some nice fractions. You could also write it in, say, a decimal form. I'm just making that general conversion. To go the other way, let's say I want to convert to degrees. We're going to multiply by 180 degrees over pi. So to convert to degrees, multiply by 180 degrees over pi. Let's say I have pi halves. There's my radian measure. I want that in degrees. I'm going to multiply this by 180 over pi. Let's see, the pi's cancel. 2 goes into 180 90 times. That would be a 90-degree angle. Let's say up here like 2 pi over 5. Okay. 2 pi over 5. I'm going to multiply that by 180 over pi. Again, my pi's, they'll cancel out. And go 2 times 180 is 360. 360 divided by 5 would be 72 degrees. All right, so we have two different ways. Going to degrees, 180 over pi. So I'm going to multiply by going to radians, pi over 180. The way that I remember which one it is, the one I want's on top. If I want degrees, the 180 is on top. If I want radians, the pi is on top. The reason this works is because 180 degrees equals pi radians. Here's my standard conversion. 180 degrees equals pi. So when I was multiplying by pi over 180 or 180 over pi, I was really just multiplying by 1, which isn't going to change the overall value, but was changing the units I was working in, degrees versus radians. Okay. Some other ones that we want to make sure that we definitely get to know. If 180 degrees is pi, well, 360 degrees, if we went all the way around the circle, that would be 2 pi radians. 90 would be pi halves radians. So that's half of 180. 45 would be pi fourths radians. 60 pi thirds radians. And 30 pi 6 radians. So these are going to be our most common ones. These are what's involved in our special right triangles, 30, 60, 90, and 45, 45, 90. We're going to see those a lot. Those will show up quite a bit. So I definitely want to get used to the fact that I know pi 6 is 30 degrees, radians versus degrees. And that doesn't mean we won't ever have to deal with that 72 degree angle that I had a few minutes ago, or 227 degrees, and converting those to radians, or take a radian, non-standard radian measure like a 5 pi 8ths and convert that back to degrees. These would be our most common ones and the ones that we get used to. Okay? Now, what do I do if I forget? Man, I can't remember. 60 degrees is pi thirds. I'm going to go right back to, if I can't remember what it is, I know I can multiply it by pi over 180. 60 goes in there 3 times. There's where I'm getting that pi thirds from. Okay. Another thing with regard to radians. Typically, we do not always see the word radians after. Okay. My measurements are in degrees, or I'm working with radian measurements. Degrees, I'll see the degree symbol. Radians, I'll just see the value. Okay. Now I've got to be careful here because I'm thinking, wait a minute, that means I'm always going to see the the letter pi in a radian measure. That is not true. Okay. We could see something like this, 3.4. And if I said that the angle measured 3.4, that means it measured 3.4 radians. If I stated the angle measured 3.4 and that degree sitting there, okay, that's a real small angle. That's even going to be smaller than that, but you get the idea. Very tiny angle at that 3 degrees. But without that degrees, I automatically know if I'm talking about a measure of an angle, that is a radian measure. Okay? Doesn't have to have a pi. A lot of them will. Most of the ones that we see will. But if it doesn't, I still know that's a radian measure. Well, we could still convert this also if we wanted to. Let's take that 3.4 and say I wanted to convert it to degrees. 180 degrees over pi. This one I'm definitely going to need my calculator for. So 3.4 times 180, divide that by pi, and this would be 194, I'll just go nearest 10.8 degrees. So a 3.4 radians is almost 195 degree angle. So that's a very large angle. Very different than 3.4 degrees. Okay, so 3.4 radians would be 195 degree angle. If you think of this guy right here to kind of give you a little bit of a reference, if 180 degrees is pi, if we're dealing with going around the circle here, I'm starting here at 0, And I'm coming around here to 180 degrees. So 195, I'm just going to kind of guesstimate about right there. There's that 195-degree angle. All of that, or 194.8. And that the way that I can equate that to that 3.4 radians, remember 180 was pi. Well, pi is 3.14. Well, 3.4 would be a little further than 3.14, kicking me down into that third quadrant. Okay, so I need to look very close sometimes. Again, a lot of times, especially when we don't see the pi, we'll see the word radians written after that. But if what we're working with, the problem, the diagram, what have you, is stating, okay, this is the measure of the angle, sometimes it will not be written. And the way that I know that's a radian measure and not a degree, I don't see the degree symbol sitting there. Okay? We can always convert to some different ones. These are going to be the ones that we'll primarily see going throughout trig and even on up through calculus and some other areas. Those are all our special angles. These can also make some of your conversions a little faster. So let's say I wanted to take 210 degrees and convert it to radians. Yes, I can absolutely take that, multiply it by pi over 180, and that will give me then 7 pi over 6. But another way I'm thinking of it is, wait a minute, 210 is 7 30s. 7 times 3 is 21. So 210 is going to be 7 30s. So that's 7 of those pi over 6s. So that would be that 7 pi over 6. Let's say we have 240. That is 4 of those 60s. So that would be 4 pi over 3. And I know sometimes we look at that and we think, excuse me, wait a minute here, 240? That's a multiple of 30. Isn't that 8 30s? And it absolutely is 8 30s. So that is 8 pi over 6, 8 of those 30s, but that still reduces to 4 pi over 3. So you do have some that will go into multiple ones. 135 degrees. That's 3 of those 45s. So 3 pi over 4. Okay. The main idea would simply be this. 3 pi over 4, 135 degrees. Those two angle measurements are in the same spot going around the circle. Okay? There's different ways of measuring it. This is referring to the total angle measure. This is referring the distance moved to cover. I covered 3 pi over 4 units to cover that angle. Two different types of measurements. Okay? But they're still measuring that same piece, all right, that same angle as far as we're looking at. 45 pi over 4, same location. 90 pi halves, same location. So just to kind of give you another diagram, typically when we go around, we got 0 degrees, 90, 180, 270, and if we go all the way around, we got 360. Well, if I'm measuring in radians, I would have 0, pi halves, pi, 3 pi halves, all the way around would be 2 pi. And so let's say I drew this 60-degree angle in here. I'm saying that's 60 degrees, but I'm also saying that that has moved a distance of pi thirds radians. Okay. So again, we're going to see radians and degrees. It's being able to work with both that becomes essential. Can I move back and forth between the two? I need to do that. I need to get comfortable with those radian measures. I'm going to see those a lot more. Okay. A couple of formulas that involve radians primarily would be if we're going to find an arc length or a sector area. So an arc length is given by S equals R theta, and a sector area would be given by pi r squared, I should say A for area, A equals pi r squared theta. Okay? In both of these cases, r is my radius, theta is my central angle in radians. So it's my radian measure of the angle. Okay? So, by an arc length in a sector area, think of, there's the center of my circle, like a slice of pizza, like that. So we're going to take a slice out of there. Here is my angle measure theta in radians. So in other words, it's the distance that's covered by that angle. This is the arc length. It's how long that arc is. Call that S. Okay? And then, of course, the area. So that would be like the length of the crust on a slice of pizza. Okay? The area would be the full area of the slice. I'll put the area in red. That would refer to the area there. Okay? So let's say I'm told, for example, that, let's put number one. The radius is 3 inches and theta is 30 degrees. Okay? And I want to find a value for the arc length and the sector area. Well, arc length is S equals R theta, so that would be 3 times pi over 6. So my angle measure in radians for 30 degrees is pi over 6. I either know that, I'm going to get used to seeing that one, but if it's one I don't know or I've forgotten, I'm going to go out 30 degrees times pi over 180. That would convert to pi over 6. Okay? We can multiply these two, and this would give me pi halves inches, and we could answer in a decimal format. Pi halves would be about 1.57 inches. That would also be fine. If we wanted the area, pi r squared theta, so pi, that would be 3 squared. There's my radius. And then my angle, again, I've got that pi 6. And that would be, what's that? 3 squared is 9. So 9 pi squared over 6 inches squared. And again, typically when we're finding an arc length or an area, many of the times we will just give it into a decimal form. So unless I calculated wrong, I got about a 14.8 inches squared, about 1.57 inches on that arc length. Okay? So again, main idea would be make sure I'm in radians. If I was given, again in number one here, if I was told, hey, yeah, the angle's pi 6. Let's get pi 6 in for my angle in each spot. Since I was given 30 degrees, first thing I want to do, convert that to radians. And then I can get it into my two formulas. Pretty quick formula. I just need to make sure I have the right units as far as what I'm working with. What if I had this? Let's say R equals, let's go 4 feet. And we'll say theta equals 5. Theta equals 5. So let's find the arc length sector area. So S would be R theta, which is 4 times 5, 20 feet. I didn't have to do anything to that 5. It's already in radians. So Remember what I said earlier? I do not see a degree symbol, so I know that's a radian measure already. Area, pi r squared theta, should be pi 4 squared times 5. Oh, what's that? 16 times 5, 80 pi. And 80 pi would definitely be okay. Then the decimal, about 251.3 square feet. So two formulas working with arc length and sector area. We'll do other things with radians, but that's two initial pieces that are using that radian measure in the formula. And again, the other part that I already erased is I need to remember that converting to radians from degrees, I multiply by pi over 180. Converting to degrees from radians, I multiply by 180 degrees over pi. And I said the way I remember it, the one I want's on top. If I want radians, pi's on top. If I want degrees, I've got degrees on top, that 180.